Now we can consider another example, that is example 2. Check the stationary and invertibility of the given process x t equals 0.5 x t minus 1 equals z t plus 0.4 z t minus 1, where z t's are the white noises. So what you have to do is, here again you have to write those things in b terms. So here xt you can write as it is, minus xt minus 1 we can write in b using b operators, b xt, right, equals here zt as it is, plus 0.5 zt minus we can write b zt, no, right. Now we can take xt terms out from the bracket, then here 1 minus 0.5 b xt equals 1 plus 0.4 b zt. So then here you can find this is autoregressive part, the 5p bxt, and this one is moving average part, theta qb times zt. And so what is here p equals 1, no, and q also equals 1. So therefore this is ARMA 1,1 process. This is ARMA 1,1 process. Now we can take for stationary. What you have to do is, for stationary we have to check this part, 5pb should be equals to 0. So then here that part is 1.1 subtraction 0.5b equals to 0, then 0.5b equals 1 and b equals 2, right. Then we have to take absolute value of b. If b equals 2, absolute value of b also equals 2, and this is greater than 1. So according to the theory, what happen if their roots are outside of the unit circle, it means roots are greater than 1, what happen is this is stationary. Therefore the process is stationary, right. Now we have to check for invertibility. So how we can check for the invertibility is, now we have to consider the other part. What is it? That is moving average part. It means theta qb we have to equal that for 0. Then theta qb means this part, 1 plus 0.4b equal to 0, then 0.4b equals 1 minus 1, then b equals minus 2.5, no. Then we have to check the absolute value of b. It means absolute value of minus 2.b, that is 2.5, and that is greater than 1. Therefore the process, since this is greater than 1, the process is invertible, right. That is not difficult one, no, that is also very easy, right. So we will consider another example, right, and we can wind up this lesson. So example 3, check for the check for stationary. Check for stationary only, right, stationary. So we have to check this is stationary or not. So what the given process equals zt equals 0.8 zt minus 1 plus 0.15 zt minus 2 plus AT. So we have to rearrange this. Why? Because Z terms in here and Z terms in here, AT terms also in here, so we can take Z terms for one side. So then we can write ZT minus 0.8 ZT minus 1 subtraction 0.15 ZT minus 2 equals AT. Right, then we can write this using B terms, B operators. 0.8 here, B ZT 0.15 B squared ZT equals AT. Now what you can do is you can take Z terms out from the bracket. 0.8 minus 1.5 here, B, and B squared ZT equals AT. So what this part is 5p BZT, and this part is that is, since AT, no, that is moving average part, right? That is theta QB AT, right? So here no B operators, no, it means here the what is P equals 2 and Q equals 0. So what is the meaning of this is, so this is ARMA model of P equals 2 and 0. P equals 2 and 0 means this is no moving average part, no, it means that is equivalent for AR2 process, right? AR2 process. Now we have to check for the stationary. For stationary invertibility we can't check here because there is no, right? Why? Because there is no moving average part, so that is 0. Then no invertible, that is not invertible. Simply we can say that. But so next we have to check for the stationary. So for that phi PB equals for 0, so it means 1 minus 0.8b minus 0.15 b squared equals 0. So this is a quadratic equation, as I told earlier. You can use the equation and find the roots for this quadratic equation. So you can find the roots as b1 equals 3.33 and b2 equals 2, right? So there are two answers for B. Now what you have to do is you have to check both them, right? You have to length, right? First modulus of b1, that is 3.33 greater than 1, and b2 equals modulus, that is 2 greater than 1. The both are greater than 1, so both roots are greater than 1. So both are greater than 1 means therefore the given process is stationary, right? So now this given process is stationary. That is how we can do calculations. So I check for the stationary and invertibility of this lesson. We discussed those examples right here. It is explained how you can find this here, given the how complete in square to solve the quadratic equation. So you can use equation, any method you like, that is up to you. And this is how we can found that one. Then we found that as non-stationary, and we take that is invertible. Then for the second example we simplified those, right? Okay, then third example we discussed, right? So this is 3.3, that is greater than 1, okay, and that is also we can find the given process is stationary. So that is so as the beginning we recall the moving average process and autoregressive process, and we learned what is invertibility, and then we discuss about the ARM model and the properties of ARMA model, that is invertibility and stationary. So how we can check is, so we have to take the to check the invertibility, we have to take the moving average part of the ARMA model, and we have to equal to that into the 0, then we find the answers for the B. Then since that roots are greater than 1, that means that is invertible. And also that stationary is, we have to take the autoregressive part of that equation, that model. Then what you have to do is you have to find the, again you have to find the roots for the B. If that is also lie outside the unit circle, it means roots are greater than 1, that you have to take the absolute values only, no need to consider the minus sign. So then that is equals 1, that is invertible. That is all about this ARMA model, and based on this lesson also you have a tutorial, and we have to do one more lesson in this course. Thank you very much.